Welcome to this explainer. Today, we're diving straight into the hidden mechanics of steering. We're going to demystify exactly how your everyday physical input actually turns a 2-ton car. It's something we literally take for granted every single time we jump behind the wheel, right? But the mechanical magic happening right under your dashboard, specifically how rack and pinion works, is just absolutely fascinating.
So, let's kick things off with the big question. How on earth is it physically possible for a tiny 15-inch steering wheel to effortlessly control such a massive vehicle? I mean, you're just sitting there, barely breaking a sweat, turning this small circle, and somehow, boom, the incredibly heavy wheels of the car pivot super smoothly on the pavement. How does that happen?
Well, the secret here is actually just basic physics. Think about it. When you turn your steering wheel from full right to full left, which is usually about 4 full rotations, the outer edge of your steering wheel travels nearly 16 feet in total. But during that exact same motion, the front wheels of your car down on the road, they only turn enough to move the tire edge about 12 inches. The entire steering system is purposefully designed to trade all that distance for force.
Here's our roadmap for this explainer. First, the magic of steering leverage. Second, inside rack and pinion. Third, how gear teeth change driving. Fourth, adding hydraulic power assist. And finally, the electric power shift.
Section 1. The magic of steering leverage. Let's see exactly how we trade distance for force.
Because we're making that trade-off, your steering input is being massively multiplied. Let me put it this way. If you hopped out of your car and tried to physically shove the road tire left or right with your bare hands, without any mechanical leverage, you would need roughly 16 times more strength. So yeah, unless you literally never skip arm day at the gym, you can thank the gears and levers in your car for making what would be a grueling workout feel like a breeze.
Section 2. Inside rack and pinion. Let's take a look at the mechanical cheat code doing all this heavy lifting.
When you get right down to it, the two core components are surprisingly simple. The rack is just a horizontal piece of metal with teeth cut right into the top side of it. And the pinion? Well, that's simply a round gear sitting at the bottom of your steering shaft. These two perfectly interlock. It's like a giant, super efficient puzzle piece that's very easy to maintain and gives you wonderfully precise control.
And they trigger this perfect, uninterrupted chain reaction. Picture this. As you steer the wheel clockwise, the pinion gear rotates and bites into the rack, physically shoving it horizontally to the right. That rack then pushes on components called tie rods, and those tie rods transfer the motion to the steering knuckles, which ultimately pivot your front wheels. It is a completely seamless mechanical chain from your hands directly to the rubber on the road. Moving on to Section 3, how gear teeth change driving. Let's talk about tweaking that drive feel.
You know, simply by tweaking the number of teeth on that round pinion gear, engineers can completely change your driving experience. If they use fewer teeth, turning the wheel becomes a total piece of cake. But you're going to have to rotate it a lot more times to take a sharp corner. On the flip side, if they pack in more teeth, you get a much quicker, sharper, and more aggressive steering response. The catch? It'll definitely require a bit more physical muscle from you to maneuver the car.
Now, even though this tech is incredibly efficient, it actually took decades to catch on. European makers like BMW were total pioneers back in the 1930s, adopting early rack and pinion systems. But honestly, it didn't really hit mainstream U.S. auto manufacturing until the 1974 Ford Pinto. Meanwhile, cars were getting heavier and heavier, and the industry realized us humans needed a little extra help. That's actually why Chrysler introduced the very first production power steering way back in 1951.
Which brings us to Section 4, adding hydraulic power assist, the first real power-up for those heavier cars.
So instead of relying 100% on your muscles to shove that rack and pinion around, this system pairs it with a cylinder and piston located right on the steering rack itself. An engine-driven pump shoots highly pressurized hydraulic fluid through lines straight into this cylinder. And that fluid pressure, it acts like a massive mechanical muscle, amplifying the force you're putting into the steering wheel. But the absolute genius of the whole setup is the rotary valve. As you turn your steering wheel, this clever little control valve instantly detects which way you're going and directs that pressurized fluid to the correct side of the piston. So the fluid pressure is doing the heavy pushing for you. This is what makes steering feel incredibly light and effortless, especially when you're trying to parallel park at really slow speeds where tire friction is at its absolute peak. But there's a rather dangerous catch to this hydraulic setup. Since the pump is driven by a belt connected directly to the engine, it relies completely on that engine actually running. If your engine randomly stalls out while you're driving, bam, you lose that assistance instantly.
Your steering wheel suddenly becomes doubly heavy because now you're not just fighting the full weight of the car, you're also fighting the dead fluid and piston inside the power assistance system itself.
Let's jump into Section 5, the electric power shift, upgrading to smarter steering.
The contrast between the old hydraulic systems and the newer electric ones is just night and day. Electric power steering, or EPS, ditches that constantly running, engine-draining hydraulic pump and replaces it with an intelligent electric motor. Because it doesn't need an engine belt, it keeps working perfectly even if your engine stalls out. Oh, and as a bonus, there's absolutely no messy, environmentally hazardous hydraulic fluid to leak all over your driveway.
By constantly reading sensors and checking in with an internal computer, this electric motor knows exactly when and exactly how much torque to apply. It only draws power when you are actively turning the wheel, which is a huge win for fuel efficiency. Plus, the computer can completely tailor the driving feel. It gives you a highly responsive, custom drive at any speed, perfectly tuned to whatever specific vehicle you happen to be driving.
Okay, so what if we took this evolution to its absolute logical extreme? What if we completely removed our mechanical hero, the physical rack and pinion, from the equation entirely? Welcome to steer-by-wire. This relies entirely on electronic signals. Your steering wheel rotation is measured by sensors, an electronic control unit interprets what you're doing, and then it beams digital commands down to steering actuators at the wheels to physically turn them. No physical connection at all.
Now, because steer-by-wire relies 100% on those electronic signals without a physical steering column, there's obviously no mechanical fallback if something goes wrong. That means it requires massive fail-safes. We're talking multiple input sensors, dual or even triple redundant communication networks, backup power supplies, and backup steering actuators on the wheels. This fail operational design basically guarantees that if one digital component glitches out, the backup systems instantly take over to keep you safe.
We've seen how steering evolved from these brilliantly simple mechanical gears trading distance for force, all the way up to highly intelligent, sensor-driven electric systems. It is genuinely an incredible engineering journey. But looking at where the tech is headed today, it leaves us with one final provocative question. Knowing just how perfectly the physical rack and pinion has served us for all these decades, are you truly ready to let go of the physical connection to your wheels entirely? Definitely something to think about the next time you effortlessly back out of your driveway. Thanks so much for joining me on this explainer.